Welcome, listeners. This is Sanjog Aul, your host, and the topic for today's conversation is what the Internet of Things means for manufacturing. And I have with me Simon Jacobson. Simon is the Research Vice President with Gartner. Hello, Simon. Thank you for joining us.
Thank you. Happy to be here.
So everyone is talking about the Internet of Things, and it's a big topic with a lot of exciting possibilities. But we wanted to zone in on one industry today, and that's manufacturing. We want to find out what are some of the challenges coming up and which applications are making the most impact, and the evidence out there to show this is a game changer. So, Simon, as a first question, there's a lot of hype, as we know, is surrounding the Internet of Things overall. Well, what is that is specifically considered as exciting and revolutionary? And to that, since we're talking in context of manufacturing, what are the manufacturer's goals?
That's a great question because I agree. There's a lot of hype, but there's also a lot of opportunity. Our own forecast data at Gartner really looks at some of the real positive economic impact, which is estimated at over 1 trillion. So you think it's definitely going to be substantial. It's going to have impact. But when it comes to manufacturing, there's a bit of a different slant we have to look at here, and it's part of the bigger picture. If we take a step back and look at the term digital manufacturing, you'll see it's been around for eons. However, has it really lived up to its expectation, though? Over the past 8 to 12 months, I've been working with several of our clients and also moderating multiple roundtables on the topic. And each instance, it's very clear that the original definition of digital manufacturing, that is the usage of digital model to validate factory design and manufacturing processes, has not even lived up to a sniff of its original expectation. So when we look at this bigger picture of digitization and digitalization of the business as a whole, or the boundaries between the digital and physical worlds are blurring, and the people, the businesses, and the things in and across factory and company boundaries are equally as blurring, there is opportunity massive for CIOs, but also for manufacturing strategists to use the Internet of Things, to use big data, to use cloud computing, to really redefine and transform the role that production plays in the value chain. The challenge, though, and where things will become dicey, especially for the office of the CIO, is the pace at which this is happening. Business and technology innovation are concurrently accelerating in manufacturing, whether it's through connected products, whether it's through new business designs. As an example, there's one organization who is producing very sophisticated products where the products themselves are going to come down the assembly line and dictate how they're going to be assembled to the equipment. This is massive. In the past, manufacturers have had a luxury of adopting technology at a pace comfortable for them, but that is significantly changing. So for the CIO and the CIO's direct report, understanding how to, in a very competitive environment, change the wheels on moving buck, so to speak, is going to be an issue.
So, Simon, if M2M communication already exists and sensors and big data are already being implemented within the organization, how do the broader applications as part of IoT make an impact on the whole?
Well, here are some of the technologies exist today, and there's a question we need to ask about that is really what's new, but also have these technologies really been leveraged to the fullest? M2M communication, tags and sensors, those are all coming down in cost. So the barrier to entry for an organization to, say, participate in the Internet of Things is definitely being lowered. That said, for a pure IT perspective, it's not just the way that we're capturing the data, but also the way that the data is managed, which, yes, big data comes into this. But the reality is the term big data in manufacturing is a bit dated already. Manufacturing environments already are producing extremely large volumes of information. This is where process data historians have been used for years. So if anything, it's more of how to put context around the information in the system. What do we understand and what do we do with it? There are machines and sensors that fit into the context of a process or into a larger system. That's nice, but is that important? Not always. But for organizations, the big thing here when looking at these technologies is how to create the appropriate system that maps to the end-to-end process. And now with the proliferation of data and information, the real change is we can now use external information to start to create these models and determine what the appropriate outcome for the business is going to be versus perhaps doing things at a later date or when risk has already happened.
So why does this actually matter, or why should this matter at all to the manufacturing CIO or business leaders?
It matters because if we look at the overall macro trends in manufacturing, where we have more increasingly connected products with decentralized or localized factory networks, each must be optimized frequently to produce a customized product at a higher velocity in a much more sustainable fashion. What we've seen is a lot of movement towards individualization or mass customization. And if you're going to do this in manufacturing, you still have to maintain alignment with your supply management or logistics functions, as well as with your partners to ensure that all service levels are maintained. For example, the organizations that are starting to pilot a ability for a consumer to go online and configure their own label, have it put on a can of deodorant or on shampoo and go pick it up later that day at a depot, means that I have to have knowledge of my processes and optimization of my processes at a hyper level, not just simply understanding at week's end or at the end of a shift when I need to make adjustments and improve.
Now, to what extent are organizations already adopting some of the business applications being offered on the road to this Internet of Things? And what are some of the challenges that are coming up related to cost, people, technology, and security?
I'll be very quick in terms of the business applications because analytical applications that you would find under the enterprise manufacturing intelligence or EMI market or manufacturing execution systems are not new. Sensor networks and tags are not necessarily new either. In fact, what we are seeing is maybe a renaissance or a revisitation investments in industrial automation. But the bigger challenge that is going to happen here is how manufacturers balance repeatability and lean concepts with the paradox of agility, digitalization, and constant change that is critical in today's market environment. And with that, we're going to see some different challenges that we wouldn't have seen in the past, which are really much more organizational and perhaps security oriented. And I want to take on the security one, as this is very important for manufacturing and the Internet of Things. And in fact, it comes back to that IoT discussion. If you consider this scenario where valves and motors and other devices in a production facility are monitored and controlled by purpose-built automation control systems, well, these systems are really built on building blocks like standard IT technology. They also incorporate significantly large proprietary elements. So it's not just physically securing the facility so security will be complex. It's how to use a blend of approaches from mobile and cloud-based architectures with this industrial control and automation of physical security to make sure that information and processes are managed. And this comes back to, especially in the manufacturing environment, some of the skill sets are going to have to be required here. But those cultural divides that have existed between the engineers and the process control teams that have long been associated with OT and the IT teams that are now coming in and managing the manufacturing environment means really bringing together teams that have different approaches to security. And these combined staffs are going to have to work together to develop architecture, governance, and compliance. The other things you're going to see here, besides this, is just on a pure ITOT level, just the necessary ways that organizations are going to have to come together. The engineering skill sets are at a premium. So how do I take that knowledge or the subject matter experts that reside within individual sites, get them to interact and intersect with the IT teams and scale that across the manufacturing network? The other challenges you're going to start to see is really looking at some of the future generation of technologies. How will smart machines and cognitive computing enhance or support existing skills? And of course, the last thing I would bring up here is really convincing the vice president of manufacturing or the manufacturing leadership that IT is more than just a necessary evil. That really has to be overcome. A lot of the vice presidents of manufacturing or business leadership of manufacturing that I work with tell me that I need to learn about the values of these technology beyond the buzzwords. And how do I do this without compromising asset utilization, quality, or margin? For example, I mentioned big data. Manufacturing operations have generated big data before it was a term. What does it really mean and what is the value of it? And once that value is understood and people start to experiment, we'll then start to see perhaps a bit more of an uptick in more wholesale deployment or wider scale projects within the Internet of Things.
So what types of manufacturing organizations are adopting this the most?
There's going to be significant differences between industry orientation. In discrete industries where there is a high amount of very complex bills of material and complex assemblies and sub-assemblies that have been digitalized for quite some time, or at least are increasingly digitalized, you're going to see much more of a focus here on the connected products and how to ensure that there's going to be a different orientation of producing these products, ensuring there's a more concurrent feedback loop from the market or from the production process as to how these products are designed. In the process industries where you tend to run the assets a bit more all out, you're going to see a higher premium being placed on things like reliability, ensuring that the assets are available and there. And it does open up the door for some of the predictive maintenance or reliability-centered maintenance discussions. But more importantly, in those industries, it's also going to be how to access the information to ensure how to optimize the process and perhaps produce the highest quality and best cost product at the lowest cost to the organization.
So this is a great segue because I was just about to ask you which IoT-enabled business applications, such as predictive maintenance, are currently making the most impact in the manufacturing industry, and where are the manufacturers finding the most ROI?
In most cases, the ROI itself is going to be from pure visibility into process performance. If you look at the majority of manufacturing environments, there's always been some form of automation and control. Whether or not that pocket of automation or those silos are connected from an end-to-end perspective. For example, I might have a CNC device or a lathe that I use, but that's really not connected to the factory network. So I have no idea of whether or not my tolerances or my processes are in control, what my process capabilities are. While a packaging line is much more automated, and I will know what the efficiencies are. Being able to connect those dots and derive context of how processes are performing is absolutely going to be where the ROI is coming from. So predictive maintenance is definitely something that will have an impact, and that falls into something I'd say of a bigger concept that Gartner's researched around asset performance management, which is really encompassing the capabilities of data capture, integration, visualization, analytics that are all bound together with the explicit purpose of really optimizing asset performance and driving that availability. This does not obviate the need for, in some cases, investments in manufacturing execution systems or even a pure physical process control software.
The claim is that by the way of intelligent capture and analysis of data in the field, IoT will help with downtime minimization, pricing optimization, and yield management, among others. But do we have enough existing proof that these claims are accurate, or are they just hype so far?
I would definitely say these claims are accurate, but let's look at this through the appropriate lens. Going back to 2001 and 2002, the term enterprise manufacturing intelligence came to be back then. And that really focused on the ability to use information technology to distill specific KPIs that are generated from multiple data points gathered within a factory or a production process. And a lot of that helped organizations within specific pockets or by asset individually minimize downtime or optimize yield. The challenge that organizations have now is tying this all together. So the ROI and the value is still there and there is proof. But with that in mind, you have to look at how this is going to tie to manufacturing's ability to be a value add. So the ROI statements and the value is going to change. And the big thing that's going to change this is how the data is collected across multiple stages of production to drive a level of transparency. This is going to enhance process visibility, process knowledge, and process understanding, which will in turn impact downtime and asset management. It will impact the ability to do more dynamic pricing, but also drive quality improvements, that is. So this end-to-end view, if anything, is going to integrate the execution capabilities of production with the broader supply chain. And that's going to have a specific outcome to the business of increased flexibility, improved process capabilities, as well as the continuous optimization of production rates and the locations that products are produced at. This in turn will help meet changes in demand and different product designs while giving the business a level of agility to respond to other externalities. This means that some measures of product quality can be refocused and the subsequent cost savings added back into the business or to its external suppliers and partners. The savings can also be driven into other value-added processes and consistently aligned with varying customer segments. But absolutely, there's going to be significant value here, and the Internet of Things really going to tie in more information to these processes.
Predictive maintenance is an application that OEMs could actually package into their products. If you look at it in this way, it could be a revenue-generating opportunity. So are there any other examples of opportunities like this? Who is also going to most benefit or profit out of the usage of such business applications? Let's talk about this when we come back from the break. Please stay tuned, listeners.
Bosch Software Innovations is proud to sponsor this program. Visit www.bosch.com www.bosch-si.com/connected manufacturing to find out how Bosch can help you improve your operational performance and become a manufacturing industry leader in a connected world. Change the way you predict, manage, and produce outcomes. Bosch Connected Manufacturing.
You are listening to CIO Talk Radio Analyst Corner.
Welcome back. So let's explore this area. Simon, you're talking about predictive maintenance as an application which OEMs could actually package into their products. What about other types of applications? What kind of opportunities that are existing which could actually help generate revenue?
Predictive maintenance in and of itself there's a lot of money to be made with the assets. As I mentioned earlier, there's a bigger concept here of asset performance management, as reliability of assets is being placed at a higher premium these days. And as I mentioned, we've defined asset performance management as really the data capture, integration, and analysis of information off of specific assets to drive availability, minimize costs, and reduce other operational risks. And this includes different but often complementary practices like condition-based maintenance, predictive forecasting, risk-based maintenance, as well as it's also historically resided in the shadows of enterprise asset management, but being put a bit more to the forefront as reliability is further prioritized. And quite frankly, there already are folks generating revenue in doing this. If you were to look at the aircraft engines business in particular, where the large OEMs would sell powered by the hour or performance-based logistics contracts on top of the asset, yet what they're guaranteeing is uptime. And when you guarantee these kind of outcomes to the customer, that you have to look at this from two different perspectives. How I monetize this, but also how my customer monetizes this. And this is where vendors like GE, vendors like ThingWorx, who have been since acquired by PTC, Honeywell, and Rockwell Automation, just to name a few, have built offerings both for their OEMs, but also for the customer directly. But this really opens up the bigger question and the bigger issue. It's not exactly how companies individually are going to benefit. It's more of who's going to profit from the usage of the applications as part of a broader digital business scenario, which is really around joint value creation, where everyone's making money and you're not just saving $1 here and $20 there. That's something that has to be addressed, and that's part of the whole collaboration aspect that performance management encompasses.
Now, an interconnected enterprise will likewise make the supplier and value chain network increasingly more complex. Have manufacturers been able to handle that new level of complexity in order to see the benefits of a connected enterprises? What do you think? What challenges are still remaining?
There's a significant amount of challenges here. First of all, complexity is not going to be tamed anytime soon. You asked about supplier and value chain network. Let's also look at the complexity of product portfolios. There's several consumer products companies we're working with who are trying to limit the amount of SKUs or stock keeping units that they have. You start to look at the aftermarket and then trying to understand the demand, especially on the discrete side of the world, for specific spare parts and how to forecast and build that. So the complexity is mounting. What manufacturers have to think about in order to see the benefits is really coming back to some of the basics. And this is where I like to ask clients the question of, if you were to build a manufacturing company from the ground up, what would you need? And really what it comes back to is a couple of basic pillars. The first being just a pure production system of codified and standard work and best practices that is going to evolve and be continually improved on over time. That way, as changes to the business as in manufacturing can adapt. The second piece is going to be really how I manage my information. In some cases, the need to manage product data, like such as built material. In other cases, the asset data. And what you find for a lot of organizations in this case is the whole paradigm of manufacturing systems architecture has to be flipped upside down. We continue to perpetuate architectures that make data go to the applications, when in reality, you have to start looking at applications that go to the data. And to do that, different delivery models, both from a deployment and pricing perspective, need to shift, but also in this connected world and this complexity, there has to be a tighter effort on some of the information standards as well.
Now, what's the current market like for an IoT-enabled manufacturing transformation? How effectively are providers able to help manufacturers fully leverage IT and see IoT's full potential?
I would be very careful in claiming an IoT-enabled or Internet of Things enabled manufacturing transformation. When we look at manufacturing transformation as a whole, performance maturity of a company for individual divisions, depending on the organizational structure, has to be taken into account. This is where a lot of organizations will struggle. In mature businesses where manufacturing operations are integrated with the end-to-end supply chain, these approaches are going to start to take root. Leaders are able to transition manufacturing from a cost center, asset, and capability to a brand enabler, and they're going to be able to connect with different value chain partners in their products to do so. A lot of manufacturers work so hard to optimize for today's business environment, and they're going to struggle to successfully capitalize, and they risk missing the opportunity that's happening now, and they're going to end up playing catch-up. This means from an IT perspective, and this is where I'm cautious around an IT-driven manufacturing transformation. While manufacturing environments generate a large amount of data, and the term big data might not be new, the reality is, though, a lot of these advances in technologies are also going to unmap how deeply entrenched many factories are in what we'll call a spreadsheet of things. Instead of being prone to reaping your rewards, an uncomfortably high majority of manufacturers still rely on paper, manual data capture, and in many cases, Microsoft Excel for information gathering and analysis. And those instances, you have to really digitize some processes before you can really drive an Internet of Things. So what I see a lot of organizations starting to think about is, let's look internally, understand that the Internet of Things doesn't always have to be on the internet. Maybe we also start to develop an intranet of things. That way, before manufacturers can start to think about multiple processes and supply points, they can start to connect the dots within their own houses, so to speak.
Which applications, which may be difficult to integrate into today's processes, will be the most profitable and promising moving forward into the future?
Not going to be one killer application. There's a lot of moving parts within the Internet of Things, and when you put it in the industrial context, you have multiple moving parts because of the heterogeneous set of systems that live within every factory. So we're going to have to look at this from a broader architecture where different classes of applications have to be considered. Whether it's the large industrial automation providers like the GEs, the Rockwells, and the Schneider Electrics of the world, whether it's the PLM providers who are going to help with some of the concurrent management of product and process design, folks like Siemens and PTC. But then there's also the entire security aspect of this, where Cisco will definitely have an impact. So we're starting to see that multiple players sit on this landscape, and this doesn't obviate the need for traditional manufacturing intelligence or manufacturing execution systems. The question is going to be is how companies put together the appropriate architecture and how the application providers start to put together a reasonable level of open standards for everyone to adopt, that the interoperability and the flow of information becomes much more streamlined and seamless. That way we can start to see things like an app store similar to iTunes for manufacturing.
Once again, thank you, Simon, for sharing your thoughts and insights on our Analyst Corner segment.
My pleasure.
And listeners, I invite you to find more conversations about the Internet of Things and manufacturing as part of our series at ciotalkradio.com/connected manufacturing.